All right, now we're going to get into the mathematical side of phase changes. We have a total of 3 problems we're going to do here. So we're not doing a lot of problems, but they do take a while. So make sure you get out your calculator and take notes. Okay, so what we're trying to figure out is how much energy is consumed when 25 grams of water is heated from 4.5 Celsius to 56.7 Celsius. Now, folks, what you really need to do is think about these. There is no magic bullet here. You really have to think about what's going on. All right, you got 25 grams of water, so you need a mental picture of 25 grams of water, and it's being heated from 4.5 Celsius to 56.7 Celsius. What does this tell you? 4.5 Celsius. What state is the water in? Well, it's a liquid at that state. And what state is it at 56.7? Well, it's still a liquid. All right, so all we're doing is a simple thing where we're heating something up that's a liquid. So what you need to do is think about it and maybe even draw it on your phase diagram if that helps you, where you're starting down here and you're ending up here, and it's all within this one state of water. Well, we know what the specific heat of liquid water is. We've been using it for all of these podcasts, which is 4.18 joules per gram degree Celsius. So what you're going to do is you're going to look at that chart that you wrote down from the last podcast. Yeah, I told you you'd need it. Right? And here's your 4.18 joules per gram degree Celsius. So you're going to need that as you go and work through your problem. All right, so how much energy is consumed? Well, what's energy? Well, remember, we're going to say that energy, we're measuring it in joules, and that's Q. And Q equals mc delta T. So how much is my delta T? Well, my delta T here is simply going to be 56.7 minus the 4.5. So it's going to be 52.2 degrees Celsius. So that is my delta T as I'm doing this particular problem. Okay. So, sorry, I'm looking for my answer here. So my Q is equal to my mass. My mass is 25 grams. My specific heat is 4.18 joules per gram degree Celsius. And I'm multiplying by 52.2 degrees Celsius. All right, so my degrees Celsius is going to cancel. My grams are going to cancel. I'm going to be left with joules, which is what I want. And it's imperative that you realize this is joules, folks. All right, so when I do that math, I come out with 5,455 joules of energy, which is the same as 5.455 kilojoules of energy. Either answer is perfectly acceptable. There are 2 sig figs in my question, so I'm going to come up with 5.5 kilojoules of energy, or 5,500 joules of energy. Either answer is perfectly acceptable. All right, so let's look at our second question. Our second question is how much energy is consumed when 25 grams of ice is heated from -20 to water at 60? Whoa, that's a lot harder. So again, we have to think about what's going on here, and notice we're going from -20 to +60, and we're going from ice to water. All right, so where are we? Well, we're starting at -20, which is down here, and we're going to water, which is up here. So we actually have 3 things that are happening. We have one thing here where the ice is heating up, where it gets up to 0 degrees Celsius. And then once we get there, we have to keep putting heat in. And for our heat of fusion, we have to look at this where water is melting. And we have to melt all of that water at 0 degrees Celsius. And then we have to go all the way up to here when that water is heated up again. Now this one we know is 4.18 joules per gram degree Celsius. Well, what we have to do is look all of these up on our table so that we know which pieces go where. All right, so let me just go and look down here. I notice my heat of fusion is 40.7 kilojoules per mole. So this is 40.7 kilojoules per mole. So notice, again, this is moles, this is grams. You'll notice there's no degree centigrade down here. Why isn't there any degree centigrade? Well, because your temperature is not changing. Your temperature is staying at 0 degrees. But your temperature is changing down here where the ice is warming up. and that one is 2.11 joules per gram degree centigrade. So this part is 2.11 joules per gram degree centigrade. So I notice that these are in joules per gram degree centigrade, these are in joules per gram degree centigrade, but this is in kilojoules per mole. All right, so I'm going to have to do some conversions here to make this work. All right, so let's go ahead and look at what we're going to do. We're going to do a three-step problem. All right, the first thing we're going to do is take the ice, and we're going to go from negative 20 degrees Celsius up to 0 degrees Celsius. So I have a change in my temperature of 20 degrees Celsius. All right, and I know that Q is equal to mc delta T. All right, so what does that tell me? Well, my mass is, how much do I have? I have 25 grams. So I have 25 grams of ice. And my C, my specific heat, instead of being 4.18, is going to be, well, my specific heat for ice is 2.11. So it's 2.11 joules per gram degree Celsius. And my change in temperature is 20 degrees Celsius. All right, so my degrees Celsius cancels, my grams cancel. I'm left with joules, which is what I want. Right? So that answer, when I actually sit down and do the math, is going to be 1055 joules. All right, now that's what it takes to heat up the ice. Now, the second thing I have to do is I have to go from ice to water, to liquid water, and all of that happens at 0 degrees Celsius. So I actually don't have to go and have any temperature to worry about because my temperature is not warming up. Okay? So here what I know is that my delta H is equal to my kilojoules per mole of water. Right? Isn't that what I'm given? Let's see. Well, I'm given kilojoules per mole in my heat of fusion, and that's 40.7 kilojoules per mole. All right, so let's just write that up here. That's 40.7 kilojoules per mole when I'm going and converting ice to liquid water, from solid to liquid water. Okay, so if I want to now get kilojoules, well, my kilojoules are equal to my delta H times my moles. Well, how many moles do I have? Well, I've got 25 grams. Right? Well, that doesn't work. So what I have to do is I have to stop for just a minute and have to say, well, if I have 25 grams of water, I have to convert grams of water to moles of water. And if I figure out how much water weighs, I figure out that's 18.015 grams in 1 mole. Now, if I do that math, I come out with 1.388 moles of water. All right, so my delta H is 40.7 kilojoules per mole, and the number of moles I have is 1.388 moles. So my moles cancel, and I'm left with kilojoules. So my kilojoules here is going to be 8.34 kilojoules. And that's how much energy it takes to melt the ice. This was how much energy it took to warm the ice up to 0. Took it out of the freezer, warmed it up to 0. This next one is how much energy it took to melt the ice. And now my last one is going to be my water, my liquid water. And it says it's going up to 60 degrees Celsius. So it's going from 0 degrees Celsius up through 60 degrees Celsius. So that's a 60-degree temperature change. So my delta T is equal to 60 degrees. And I know that Q is equal to mc delta T. This is the one I'm familiar with. Okay, so I'm dealing with 25 grams of water. And my C, this is the 4.18 joules per gram degree centigrade. Now, if you've been doing all the worksheets, you're at the point where you don't have to look that up. Now, it's here, so you can look it up. It is on this chart. You have 4.18 joules per gram degree centigrade to heat up liquid water, right? And my delta T is 60 degrees Celsius. Right, so my degrees Celsius cancels, my grams cancel. I'm left with just 25 times 4.18 times 60, which gives me 6,270 joules. All right, so now you say, I'll just add them all up. Whoa, be careful. Your units here are in joules, your units here are in kilojoules, and your units up here are in joules. Guys, I don't care if you work in kilojoules or joules. Right, so since I've got two things that are in joules, let's convert this to joules. So that's going to be 8,340 joules. So I can add these whole things up. So I've got the 1055 joules. That's what it takes to bring the ice from -20 up to 0. I have 8,340 joules, which is what it takes to melt the ice. And then I have 6,270 joules, which is what it takes to take all of that water, which is at 0 degrees Celsius, and bring it up to 60 degrees. Okay, so let's add all those up. And I get 5, and I get 6, and I get 6, and I get, let's see, 8 and 6, 15, right? So that's 15,665 joules, which translates into 15.665 kilojoules. If I look up at my problem, I only have 2 sig figs, so I'm going to round to that. So it's going to be 16 kilojoules of energy is going to be my final answer. Wait a minute, I added those. That's wrong, so I end up with one more sig fig. So it's 15.7 kilojoules of energy. All right, that was a long problem, but that's sometimes what it takes. Okay, let's look at problem number 3. This is the last one, and actually it's the worst one. Again, you have to think about what you're doing. You're starting again with 25 grams of ice, and it's going from -20. We just did that. But we're going to steam at 150 degrees Celsius. Wow, so now we have, if we think about what we're doing, we're starting all the way down here at -20, and we're going all the way up here to steam. So we actually have to go through 1, 2, 3, 4, 5 steps to make this happen. Right? So we're going to go through those 5 steps. But I'm going to skip as much work as I can. So if we look at this problem, we notice we're starting with 25 grams of ice at -20. Well, that's exactly what we did last time. All right, and that was this first piece right here, and that took us 1,055 joules. And then this second piece where we took the ice and we melted it, that was the 8.34 kilojoules. Now that part is still the same as it was last time. Now, the third time we're going all the way up to 100 degrees Celsius, so now I have to start to do some new work, right? So, again, the important part is we already have this piece, which we did in the previous question. We have this piece, which we did in the previous question. Again, it's for 25 grams of water. So I'm just going to do the last 3 pieces for you. So, the first piece, which is heating up the ice, right? We said that was 1055 joules. All right, and our second piece, which was melting the ice and making it into liquid water, that was 8.34 kilojoules. Right, now we have to do the next part, which is taking the water and heating up the water, the liquid. We have to heat that, and that's Q equals mc delta T, and that is, let's see, our mass is 25 grams, our C is 4.18 joules per gram degree centigrade, and our delta T is 100 degrees, because we're going all the way from 0 to 100, right, and that is equal to 10.45, well, let's just do it this way, 10,450 joules. All right, so now you have to boil the water. Ooh, this one is just an amazingly large number. So remember, we said that it should be a lot more than this. So let's see what happens. So when we boil water, the thing that we know is that our delta H is equal to kilojoules per mole. And we know, if we look back at this number, that it takes 40.7 kilojoules per mole to vaporize water. All right, so we're going to take kilojoules per mole. So our kilojoules is going to be 40.7. We want, what we're trying to figure out is kilojoules, right? So our kilojoules, if we want to solve for kilojoules, our kilojoules is equal to delta H divided by moles. Now, kilojoules is delta H times moles. Let's do our algebra right. Multiply both sides by moles. Kilojoules is delta H times moles. Our delta H is 40.7, and that's kilojoules per mole. So we have to multiply by moles. And how many moles do we have? Well, again, 25 grams of ice. We figured out in our last problem that 25 grams of water, 25 grams of water is 1.388 moles. So this is 1.388 moles. And if I multiply that out, I get 56.48 kilojoules. Guys, you have to be careful with units. This is kilojoules, that one's joules, this one's kilojoules, that one's joules, and the last one we have to do is heat up our steam. And our steam is heating up by 50 degrees Celsius. So again, we go back to our Q equals mc delta T, and that is, our mass is 25 grams. Our C we have to look up. Our C for steam is 1.7 joules per gram degree centigrade. So it's 1.7 joules per gram degree centigrade. And our change in temperature is going to be 50 degrees because we're going from 100 up to 50 degrees Celsius, 150 degrees Celsius, right? So that gives us a number of 2125 joules. All right, well, since we're going to come up with a really large number, let's convert everything to kilojoules. So it's going to be 1.055 kilojoules plus 8.34 kilojoules plus 10.450 kilojoules plus 56.48 kilojoules plus 2.125 kilojoules. Guys, I am assuming you can just look at a number and say joules, kilojoules. You are simply dividing by 1,000. You're moving the decimal point 3 places, right? When I add all of these numbers up, I get a total of 78.5 kilojoules. A lot of energy, all right? And realize that most of your energy is sitting right here. Most of your energy of that 78, 56 of it, or like 60, 70% of it is boiling the water. Right? So that's it. You need to make sure that you can figure out where you are on this graph. Now, again, you'll be given all of these numbers on your test, so you don't have to memorize them, but you have to be able to apply that information to your phase change diagram for water. All right? And units are critical. So you have to think about whether you're dealing with joules or kilojoules, and you have to know whether you're dealing with grams or moles. You have to think about that and use your head. Again, there's no magic bullet. You have to be able to think through this and reason through it. Match your units. Units are critical. All right, folks, you got to do the worksheet. You got to do these problems. You got to practice it. There is no way you can do this on a test without practicing it. Okay, so please, please, please practice this. All right, and if you have questions, please see one of us in class. We'll be happy to help you. Okay, take care. See you soon.